Chapter 4, The Electronic Structure of Atoms, Part 2. Part 2, Atomic Orbitals and Valence Electrons. Contents: Atomic Orbital Definition, Valence Level and Valence Electrons, Problems, Solutions, Atomic Orbitals and Types, S orbitals, p orbitals and its types, d orbitals, f orbitals. Table of orbitals and sublevel arranged on individual principal energy level. Table of orbitals and sublevel arranged on individual principal level. Summary. Atomic orbital definition. Atomic orbital is the region of space around the nucleus where the probability of locating an electron with a given energy is greatest. These orbitals are associated with characteristic energies, sizes, shapes, and orientations in space. Valence level and valence electrons. The outermost principal energy level of an atom is called valence level, and electrons that occupy this level is called valence electrons. Valence level is important in regard to the way in which simple bonds are formed between atoms. When we observe periodic table, we discover that valence electrons are found only in s and p orbitals. Thus, the number of valence electrons is between 1 and 8. Problems. Problem 1. What is the valence level of sulfur? Atomic number 16. Problem 2. How many valence electrons does an atom of sulfur have? Let's solve the problems. Answer 1. 3. 1s2, 2s2, 2p6, 3s2, 3p4. Answer 2. 6 electrons, 3s2, 3p4. Atomic orbital and types. An atomic orbital is a place where an electron with specific energy is most likely to be located. There are many different atomic orbitals and each orbital is associated with a specific letter S, P, D, F, G. Every atomic orbital, no matter with its designation, can accommodate only 2 electrons. We use these terms for following. An orbital that contains no electron is called empty. An orbital that contains 1 electron is called half-filled. An orbital that contains 2 electrons is called filled. S orbital. There is only one type of S orbital. It is present on every principal energy level 1, 2, 3. Example, 3s orbital represents S orbital on principal energy level 3. Thus, S sublevel is peculiar because it contains only the single S orbital. All S orbitals have spherical shape. P orbital and its types. There are 3 types of P orbitals designated as Px, Py, and Pz, and they are located at every principal energy level except level 1. All P orbitals have dumbbell shape as following. These 3 types of P orbitals constitute a P sublevel together. D orbitals. There are 5 types of d orbitals and they are located at every principal energy level except energy levels 1 and 2. The 5 types of d orbitals taken together constitute a d sublevel. F orbitals. There are 7 types of F orbitals and they are located at every principal energy level except 1, 2 and 3. The 7 types of F orbitals taken together constitute a F sublevel. Shapes of d and f orbitals are too complex. Table of orbitals and sublevels arranged on individual principal energy level. Table of orbitals and sublevels arranged on individual principal energy level. Summary. Principal energy level, if level is n, where n is equal to 1, 2 or 3 and so on. Then types of sublevel would be n types, S, P, D, F. Number of orbitals for level n would be n square orbitals. Maximum number of electrons would be 2n square electrons.